Hi children, how are you? I hope you are keeping fine. In the last class, we were discussing what do all acids and all bases have in common. And we studied all acids contain H plus as the common factor and all bases contain OH minus ions as common. Today, we are going to discuss what happens to an acid or a base in water solution. Do acids produce ions only in aqueous solution? Let us test. Okay, by an activity 2.9. Take about 1 gram solid sodium chloride in a clean and dry test tube and set up the apparatus as shown in the figure. Add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? Does the gas evolve successfully with a dry and wet blue litmus paper? In which case does the litmus paper change color? On the basis of the above activity, what do you infer about the acidic character of dry HCl gas and HCl solution? Take 1 gram of sodium chloride crystal in a test tube and add some concentrated sulfuric acid. Then we can see a gas is evolved from the test tube, and the presence of the gas can be tested by using a wet litmus paper and a dry litmus paper. And what are the changes takes place here? In the presence of dry litmus paper, is there any color change? See, while NaCl reacts with H2SO4, what will happen? The product formed as HCl and sodium sulfate. And this is an example for a double displacement reaction. Hydrogen chloride gas evolved here can be tested by using a dry litmus paper and a wet litmus paper. By using dry blue litmus paper, nothing happened. That is, HCl gas does not have any acidic property. Whereas, while we use wet blue litmus, what will happen? Yeah, it will turn to red. Then, let us discuss what's the reason here. When HCl gas reacts with the water to give H3O plus Cl minus in aqueous. That is the condition here, aqueous solution. Hydronium ion. How this hydronium ion formed? It is formed, listen, HCl undergoes ionization as H plus and Cl minus. Once again, HCl undergoes ionization to give H plus and Cl minus. And H plus ions in aqueous solution may combines with water. Here is the water to form hydronium ion. And this hydronium ion is responsible for the characteristic property of HCl. Okay, so acids liberate H plus ions in aqueous solutions only. That's why here dry blue litmus paper has no change, but wet blue litmus paper changed it to red. Then what about bases? When bases undergoes ionization, as we know, as Na plus and OH minus ions. And what about potassium hydroxide? Here also Ka plus and OH minus ions. And case of calcium hydroxide, how can we write the ionization? Ca2 plus plus 2 OH minus ions. So here the characteristic properties of bases are due to the presence of OH minus ions in them. Okay? So the characteristic properties of acids are due to the presence of H plus ion produced in aqueous solution, and the H plus ions produced in aqueous solution may react with the water to form hydronium ion. Okay, did you get me? Yes. Then similarly, bases ionizes as positive ions and negative ions. And the negative ions here formed are OH minus ions, and these OH minus ions are responsible for the characteristic properties of bases. And see, bases generate hydroxide ions in water. The last class we already discussed some bases only ready to dissolve in water, and that types of bases are called alkalis. Okay, so alkalis are water soluble bases. Water soluble bases. Okay, then let's pass through another type, that neutralization reaction. The last class we discussed about neutralization reaction, when a base plus an acid gives salt plus water. Listen, base, as we know, an example NaOH, acid HCl, simple example. Then listen how here the salt and water form. See, the OH of base may react with the H plus of acid. HOH means H2O, HOH, and the salt here is NaCl. The remaining ions form the salt. So it is easy to study how neutralization reaction occurs. Okay, dears? Yes. Then let us see what is involved when water is mixed with an acid or a base. Here an activity is given, activity 2.10. Take 10 ml water in a beaker, add a few drops of concentrated sulfuric acid to it and swirl the beaker slowly. Touch the base of the beaker. Is there a change in temperature? Is this an exothermic or endothermic process? Repeat the above activity with sodium hydroxide pellets and record your observations. While adding water to acids, that is, the dissolution of an acid or a base in water is highly exothermic in nature. That is, a large amount of heat is liberated as a result of a reaction of an acid with the water or a base with the water. And therefore, by touching at the base of the beaker, we feel the heat. So, the heat is due to the exothermic nature of the reaction between an acid or a base with the water. So listen, care must be taken while diluting an acid. That is, always acid to water slowly with constant stirring. Don't add water directly to acid. Why? Because as we know, the reaction between acid and water is highly exothermic. Because of the excess heat liberated here, the acid may splash out and that may cause burning or even the breakage of glass vessels in the laboratory. So, while diluting an acid, we should care how, that is, always we add acid to water with a constant stirring only. Okay? And see, the mixing of an acid or a base with the water results in the decrease in the concentration of hydronium ions or OH minus ions per unit volume. Such a process is called dilution, and the acid or base is said to be diluted by adding water to an acid or a base, which results decrease in the concentration of hydronium ion or OH minus ions. If you are taking acid, the concentration of hydronium ion will decrease. And if you are taking base, what will happen? The concentration of OH minus ion will decrease. How? Per unit volume. As the number of ions per unit volume will decrease. That is why we use the term dilution. Acid or base which is prepared by dissolving in water is called diluted one. Okay, students? Did you get me? Yes. So just conclude today's class by reminding the topics. First one, what happens to an acid or a base in water solution? In water solution, acid or a base will produce their own ions, and these ions are responsible for their characteristic properties. In the case of acid, it will produce H plus ions, and these H plus ions may react with the water to form hydronium ions. In the case of bases, they will produce OH minus ions, and the chemical properties of bases are due to the presence of OH minus ions in them. Okay? Yes. And see the next one. What are alkalis? Alkalis are water soluble bases. And next one, care must be taken while diluting an acid or a base. The reaction between an acid or a base with the water is highly exothermic in nature. So because of this excess heat produced, the acid may splash out and may cause burning and even the breakage of the glass vessels. So to avoid this, always we add how? Water to acid or acid to water? Yeah, very good. How? Acid to water with a constant stirring. And this process is called dilution. So what's dilution? The process of mixing of an acid or a base with the water. By doing this, the concentration of ions per unit volume decrease. and such acid or a base is called a diluted one. Okay students, thank you.